So you'll probably see in a lot of these videos that I'm not super creative. I enjoy taking something and reworking it and creating something new. But as far as creating things myself, maybe not the best at doing it. And so for the first actual program, we have these preloaded values in the different registers. And what we have to do is we have to take them and we'll have to store them into memory so that we can write them because we can only write from memory. And so I like otters. I hope you like otters. They're cute. They hold hands when they float around. And so what we have to do is we have to get the word otter out of the registers and put it into memory. So the first thing that we need to do is we need to actually find a place in memory for us to write to. When we run a program, if we don't say we want some memory here, the operating system won't give us any memory to actually write to. And so we'll create a data section and we'll just use the label outstring. And there's a couple of ways that we can reserve space here. For this one, we'll just do ASCII because we know how long the space is going to be. We already know how long the output's going to be. And so as a shortcut, what we can do is just go OTTER, put our line ending so we don't have to add it ourselves. And then we have the 5 spaces for the 5 letters, and we have the line ending. And when we call the write from memory, it'll automatically put that line ending there. And so we can put this in any register, except for we already have register 0 through register 9 taken up. And so we'll put the output string address into register 10. And again, we'll use the load register command because it's not an immediate, it's an address. And we'll put that in register 10. And then again with the equal sign and the label. So the first thing that we need to do is we need to find an O, and we have that in register 1. And what we're going to do is the opposite of load register, which is going to load something into a register, is we have store register, STR, and that takes a value in a register and stores it in a place in memory. And since we're only using bytes, what we need to do is we need to add a B. When we use LDR and STR without any letter after it, what happens is that it moves 4 bytes at a time. But for this, we're using 1 byte at a time. The letter O only takes 1 byte. If we did it without the B, what would happen is that it would overwrite the other 3 bytes in memory. So we need to make sure that it's very important that when we do this, that we have the store register with the B suffix. And so our O is in register 1, so we'll put 1, R1, and then we want to store it at the address of R10. And so what we do is we put brackets around R10. I think this is kind of analogous to if someone gives you their address to go to their house, you don't just take the piece of paper that has the address and look at it and say, I'm here. You actually have to go to their house. You have to actually use the address. And so without the brackets, it's like looking at the address on the piece of paper and saying, I'm here. But if we use the brackets, it's actually saying, no, the value at that number. Put store O to outstring. And so what happens is if we try this now, if we tried doing another store byte and we did the register 5, it would overwrite the O. So what we need to do is we need to take the memory address, wherever it will be, and we need to increment it by 1 byte. And so what we'll do is we'll use our add command, and we'll add 1 byte to the output out string address. And so what this does is, if you think about it, if our memory was 100, if our outstring began at 100, what we did is we added 1, so that the next time that we write there, our outstring is actually going to go to 101. So what we're going to do again is we're going to store byte, and that's going to be the letter in register 5, again to the address of R10. Again, we have to add 1 to increment the address. Again, store byte. And this is going to be the same, Otter, OTT, right? Increment the address again. And then E. Where is our E at? Our E is in register 7. Store the address at register 10. Again, increment our memory address. And then our last letter R is in register 6. And then we don't need to increment our address again because we don't have to write anything else. And so the next thing that we have to do is set up our write supervisor call, and we're going to do that just like we did with the hello world. Again, the supervisor call number for this is 4, and we'll put that in register 7. We'll move that value. And then our 3 parameters again. First parameter is the file descriptor, which for standard out is always 1. So we'll move into register 0, the number 1. And then for the second parameter, we need the address of our output string. And so we don't use move, we use load register. And again, we use the label outster for the output string address. And then the last one is our length that we're going to put into register 2. And if you think about it, our OTTER is 5, line ending is 6. So this will be 6. And then SVC 0, and that'll write to standard out. And then the last thing that we need to do again is we need to exit the program. The number for exit, the supervisor call number for exit is 1, and we'll put that in R7. And then the only parameter that we need to provide is our error number in register 0. And since there's no error, we'll use 0. And again, SVC 0. And with that, we should be fine. So let's exit this and try and running it. So the first thing we do is assemble it. Output is main.o, input is main.s. Link it. Output is going to be our executable, and we'll just call that main. Our input is going to be main.o. And if we run it, we get an Otter. So just remember, the big thing that you need to remember so far is that load register And store register is for moving data from registers to memory or from memory to registers. And move is only used for moving immediate values to registers or between registers, which we haven't done yet.